Hello, in this video let's discuss fourth question of today's contest. You are given a binary string s and an integer k. In one operation you must choose exactly k integers and flip them all. Return the minimum number of operations to make all the characters equal to 1. If it is not possible, return -1. The conditions are n is up to 1 if I and k can only up to be length and s is a binary string. If it is not possible, return -1. So the question is saying that given a binary string, flip any different k integers in an operation. And after doing any operations, the final string must be containing only 1. So if that is the case, then return the minimum operations possible. If it is not possible, then return -1. So finally the number of zeros must be 0 because all should be 1, so zeros must be 0. So let's assume that initially it is z. So after doing any operations, we have to convert that to 0 by choosing any k different indices anytime. Only in one operation they may be different. In second operation, there may be intersecting indices also. So in a single operation, we have to select k distinct. So for example, we have a simple one, 000 or 111, and k is equal to 3. So if is it 111, then the answer is simply 0. If it is 000, then we can do all in one operation, so the answer is 1. So here the string containing only 0 or containing only 1. So it is easy to think. So for now, let's assume that we have a number of zeros and b number of ones in the string. So if it is the case and we are flipping k indices, so they can be 0 or they can be 1. So let's assume that we are flipping x number of zeros. So we are flipping x number of zeros and we are flipping k minus x number of ones because combinedly it should be k. So we are flipping x zeros, so k minus x ones. So if this is the case, then finally what will be the new zeros? What will be the count of new zeros? It will be simply a minus x because we are removing x, we are flipping x, so a minus x. And these number of zeros will be added because these are initially 1 and we are flipping this to 0. So these many number of new zeros and x is the zeros we lost while flipping. So it will be simply a plus k minus 2x. And what will be the number of new ones? It will be simply b minus of k minus x because we are losing these many ones and we are getting these many number of new ones, which will be plus x. So these are the new number of zeros and ones after doing one operation and choosing randomly some x number of zeros. So if you observe more clearly, let's assume the initial number of zeros is 10. So if we have three different options, for now let's assume we have three different options. And let's assume that the number of zeros after is a1 in first operation, a2, a3 in second and third operations. So in one operation, we can get all of these. And in second operation, we can get one operation from a1 or one operation from a2, one operation from a3 and so on. So after doing all these, we have to get 0. Only then we will get the answer. So from this, we can easily understand that this is some kind of BFS. Why? Because we are given an initial point and we have many different choices at that point. And finally, after taking any number of steps, we have to find the minimum distance of 0 from the initial value. So this is exactly BFS or Desta. And as this is undirected, because this is step 1, this is also 1, this is also 1, and each and everything is a unweighted edge with a cost 1. So in this way, we can think that we can use some kind of BFS because by doing example, we got that we want the shortest distance to 0 from the initial given value. So, and what is the thing we will store in the BFS? It will be simply the number of zeros because finally the number of zeros must be 0. Initially, we can count the number of zeros, right? Let's assume that is 0. So initially, we will add this into Q and distance of this to 0 because we will maintain another distance so that we can return the distance of 0. Initially distance of z. What does this mean? It means that the number of operations to make this number of zeros is 0 because originally it is z. We are not doing any operation, so simply distance of z is equal to 0 because no operations to make z number of zeros. And initially push this into z because initially we have z number of ones and finally we have to make 0. So how can you do that? So now it is simple, right? We may think it is simple, but let's think. So now we have to select x. So here we are choosing x and only we are choosing x and only then we got the range, right? So let's assume what are the values of x. So what are the least number of zeros that can be selected at present time? So we have a number of zeros and b number of ones, which is equal to n minus a. So given these two, what is the minimum number of, what are the least number of zeros that can be selected now? So it should be less than or equal to a, right? So this is the maximum count of a. So the x should be only less than or equal to a because x is the count of a's we selected as we have seen before. So this is one condition. And then There is also restriction on ones also, because there are only n minus a number of ones. So only these many number of ones can be flipped. So similarly, k minus 6 is the number of ones, and this can be less than or equal to n minus 6. So from this both, we can get inequality of x, of which can be flipped. So this is the condition for less than or equal to a, and this is the condition for less than or equal to 1, less than or equal to number of ones. So this is the new range we will get. We will take this side and we'll bring x this side, and then we will get this. So now, but is this directly the one? So can we say x less than or equal to a directly? No, because what if k is equal to 100, k is equal to 100 and a is equal to 200? So only we can flip at most k, right? So even though if a is more, we have to take minimum of this both. And similarly, what if this is less than 0? This must be 0. Minimum this must be 0, and this maximum must be k. So we can make sure that max of these both is less than or equal to x, and x less than or equal to minimum of these both, so that no condition will be violated. And now, so we got the range of x, so we will get the range of new zeros also, because the new zeros is simply a plus k minus 2x when we flip x number of zeros. So we got the range for x, so we can simply substitute this in this, and we can get the range of new zeros, right? We can get the range of new zeros also. So now we have new zeros and we have zeros also. So we can simply get k minus 2x, which is the new number of zeros that are getting added. If this is greater than 0, this means that we are adding the zeros. If it is less than 0, we are removing zeros. Like we are ultimately removing. We can select some positive zeros, but we are selecting more ones, so that ultimately it is reducing. It is reverse. So we are selecting more number of zeros and we are selecting less number of ones. So in that case, we are getting less number of zeros finally. So in this way, we can get what are the new number of zeros that are going to add it. If that is more than, we are adding. If it is less than, we are subtracting. So we'll get the new range of zeros that we are adding. So we can try each and every possibility, right? So for BFS, we have k different options now, p different options. So we can try all those, and then we can try BFS. But that will give clearly. Why? Because there can be n different options, and it will ultimately be n squared, which we cannot do. So now what can we think of? So if we observe more, we have A and we have B. So the new zeros will be this, and new ones will be this. So A is changed to this and B is changed to this. So if we observe more carefully, K is fixed, right? And the number of zeros that are getting added is K minus 2x. So the delta zeros is K minus 2x. Why no A? Because initially it is A and finally it is A plus. So the delta is K minus 2x, and K is also fixed, which is given. So ultimately it depends only. So what if we observe more carefully? So if you observe more carefully, the parity of A is fixed. Why it is fixed? So for example, initially not fixed, but we can find it. For example, initially the number of zeros is A, and finally it is A plus K minus 2x. So minus 2x, the parity is not affected, because minus 4 or minus 6, the parity will not be changed. So ultimately the parity of A is changed to parity of A plus K, which is already fixed, right? We have A which is present, we have already K. So given A, the parity of the future number of zeros is fixed. So instead of trying all possibilities, what if we try to use this? So what if we try to use some parity? So let's say we have one. So if we have one, let's say the next possibilities are 3, 5, 7 and all. So even now, only the cells are half right. Initially, we have to check for 1, 2, 3, 4, 5, 6, but now we have to check for 1, 3, 5, which is absolutely same as before. The time complexity is not affected. Only the n square is changed to n square by 2. Even now, which will give really. So we are not getting any benefit of this. So even now, we have to traverse each and everything. So how can we think more? So here, what is the main problem? Here, the main problem is, for example, let's say we have one. So we will check for 3. We will add in the queue. We will update the distance. We will go to 5. We will update. We will go to 7. We will update all. But for example, let's say we are at 5. So at 5, we got other possibility of coming to 1 also. So if we are coming to 1 again, to check whether it is visited or not, again we have to traverse all the possibilities. So if that is not visited, then we can skip. But even checking whether it is visited or not, we have to traverse all the possibilities. So even then it will become n square. So for now, let's assume that we are maintaining two vectors. bivectors, because here what is the main criteria? Here the main criteria where we are missing out is, for example, we are at 1. So initially we are at 1, 3, 5, 7, 9 and all. So these are a set of vertices, these are set of zeros, and 0, 2, 4, 6, 8, these are other set of vertices because they are different, even and odd. So we have two different type of things. So having two different, so what if we try to maintain unvisited zeros of this type in a single vector, and unvisited vector of these cells in other vector, so that we can try to use the unvisited from these, and then we can try to not visit the same visited once again. So let's try that for now, whether it works or not. So let's try to maintain two vectors of unvisited cells. So 0, 0, 2, 4, 6, 8, and 1, 1, 3, 5, 7. So initially all are unvisited, right? Except the present number of zeros. So except that, make all initially in the first vector, all these in the one vector. So now we got two unvisited vectors. So if we visit a value, for example, we are at 3, we are visiting 5. So we are pushing the new value to Q and updating all those. And now we reached 5. So we have to remove that from the vector, but removing will take O of n. So we can use a set. So that removing a set will be only of log n, right? So instead of vector, we can use a set. So set of unvisited 2, it means that it is simply size 2. So unvisited of 0, it stores the, or it stores the even number of zeros that are not visited, and unvisited of 1 will store odd number of zeros that are not visited. So let's say now we are at present zeros, and we are at present a number of zeros, and we got minimum number of a, maximum number of a. So which is this? So we got the range of x, we got mini and max by substituting in this, right? So after getting this, let's assume the values are min and maxi. So these are the new number of ultimate new number of zeros, minimum number of zeros, maximum number of zeros. So maintaining parity. So for now, let's say we have range. So let's say minimum mini is 10 for now and max is 40 for now. And let's assume the parity is even. So if the parity is even, and for now let's assume the the count is 10. So the count is 10 and the new range is 10 comma 40. Let's assume maybe this is not possible, but for now let's assume this. And unvisited of 0, initially this is the case, initially we pushed all into this because they are not visited initially. So this is the new unvisited 0 vector. So now we have to traverse all in this, and only parity even. So we discussed, right? So even if we are storing the unvisited one, we have to traverse each and everything. So let's, so that we are using set. So now let's try to think how we are using set to make this pass, this AC. So even we have to traverse all now? Really? No. Because let's say we are at the range is 10 to 40 and assume parity is even. So unvisited of 0 contain all these number of zeros, right? 0, 2, 4, 6, 8 and so on, 44 and so on. So initially, should we start coming from 1? So should we go to 1, and should we go to 2, and should we go to 4 and all? No. Because the new range is 10 to 40. So we can start only from 10, right? So why doing all this? Why checking 0 to 4, 6, 8? So now it is 10 to 40. So start from 10. So start from 10. So how can we get the least one in this, which is greater than or equal to 10, which is the minimum number of a? So we can use lower bound. So by using the lower bound, we will get the least number of zeros, which is unvisited and which is maintaining the parity also. So by doing lower bound in this, what we can get? So we can get 10. So what is 10? So 10 is the least number of zeros that are greater than or equal to minimum a, and which is maintaining parity also, because we are doing lower bound in the parity set. So this is maintaining parity also. This is maintaining the new range also, and also that is unvisited, which we exactly want, so that it will not get into any kind of tail. So now we got this. So we got 10. So just update this. So update the distance and add into queue. So now remove this into set. Remove this from set. So we'll remove this, and then we will come to 12. We will remove this, and we'll come to 14. We will remove this. We'll come to 16. We will remove this, and so until 40. We will remove all these from set. So we removed all this from set. So from the next set of BFS for even parity, we will not encounter these because these are not in the set. Only 0 to 8 and 42, more than 42 are present in the set. So this is what we exactly want. So now the time complexity is only n log n, because the any number of zeros is encountered only twice, at most twice. After encountering, we are deleting from the set so that it will not be encountered for any other future number of zeros. So this is what we exactly wanted, and we got in n log n. But this may be very trivial. 10 to 40, we are traversing all 10 to 40 and we are removing. But this may look like the time complexity is of n square again. But is that the case? This is the case because we are doing the iteration for the first time. So for 10 to 40, we traversed all 10 to 40. But what if, let's say, the next range is 6 to 80? 6 to 80, right? So if this is 6 to 80, then we will start from 6. We will get the lower bound, which is this. So we will go to this. We will come to next set. So we will traverse this and we will come to 42 again. We will not go to 10 to 10, 12, 42 and so on, right? We will use only the set. So we have 6, 8, 42. So we will reach until maximum value, which is less than or equal to maximum value. So initially, let's say the range is 6, 80, and the number of the zeros in the set are 6, 8, 10, 42, 44. For now, let's assume and 85, 84, right? So these are the one. So we will find the lower bound in this. So this is the this is the new lower bound. So we'll start from this. So we will make updates in the queue. We will come to the next one in this, and we will update this also, and we'll update this also, and we'll update this also. But originally in the BFS we are coming to 12, and then we are checking whether it is visited or not. But now we are directly using the set only. So we will check whether this is visited or not, and then 42 we will reach 42 and we will make this unvisited, 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 and then we will reach 44. So we will make changes also, and then we will reach this. But this is more than 80, so we will stop this. So in this way, we are removing many number of visited iterations. So ultimately the complexity is unloving. So hope you got this. Let's check the code. So initially count the number of zeros. If that is 0, simply return 0. Else store distance where it is -1, because if that is, if finally it is -1, we can simply return -1. So distance of 0 is 0. Distance of z is equal to 0 because that is the initial number of zeros and no operations are required. And push this into queue and set of unvisited, and then all push all these into unvisited sets, and then shut BFS. So get the front one, pop the front one, and then find the parity of the present jet, parity of present zeros, and find the steps because we are storing. It is simply distance, right? So steps is equal to distance of a. We can use pair of q also, but this is also simple. So find the number of steps by distance of a, and then what will be the high x? High x will be simply minimum of k and x. We discussed it, right? And similarly, low is this, and then we can find min a by substituting x in the in that range, right? We discussed in this. So this is low and this is high, and by substituting L we will get one, right? That is max, and by substituting H we will get low. Why we are, for low we will get max A, for high we will get min A. Why? Because there is minus sign here. So simply min A is equal to, we will substitute high, and max is equal to low, and then find the lower bound of unvisited with the same parity. So we are using this parity set, and we are finding lower bound of min range, and then traverse all till it is less than or equal to max, and then find the value, remove that from the set, update the distance, and then simply, if the next is 0, this means that the present cell is 0. So if that is 0, so simply return distance, right? So we reach at the final one. So if it is 0, return distance, or just push into q. And finally, if we not reach this, it means that we are unable to reach zeros, so simply return -1. In this way we can find the answer. If you have any doubts, comment below. See you in the next video.